Hey kids, this is Mr. Cozy with a very special video 21.5, and with me is Natalie. Natalie, say hi.
Hi.
And we are doing solving inequalities, so let's get started. Let's look at this first example right here. And I want to open by saying that the process of solving an inequality is pretty much the same as solving an equation. So if I imagine that this is an equal sign instead of a less than sign, and I just solve this as an equation, I'm pretty much good to go. Minus 6, minus 6. I want to progressively get x alone. 1/7 x is less than or equal to -9. And then I'm going to multiply each side by 7. And I'm going to get that x is less than or equal to -63. Okay? And all of the steps that I did, I'm sorry if the hand writing is a little sideways. I'm writing at an angle for some reason. All of the steps that I did are steps that you would do if you had an equation. And therefore they're the steps that you do when you're solving an inequality. One of the big differences between inequalities and equations is just the nature of your answer. If this were an equation, then all of these equal signs would be, all of these less thans would be equal signs. And we would be left with an answer that x is equal to -63. And what this is saying is that there's only one value that x could be that would work in this equation, -63. Okay? With an inequality, it's a little bit different. Because it's less than or equal to, there isn't a single value that I need that satisfies the inequality. There are multiple values. There are lots of things that x could be, and so long as this side is less than -3, I'm good. So like let's say that x was -70. If x was -70, I would plug that in here, and I would have 1/7 of -70 is -10 plus 6 is that less than -3? And in fact it is. Okay, so x could be -70. It could also be a lot of other numbers. When I solve an inequality, I'm less looking for a single answer, and instead I'm looking more to describe what all of the answers are like, what they all have in common. And in this case, all of the values for x that would work in this inequality, all of those values are less than -63. Okay, that's why when we work with inequalities, we tend to graph them, because it gives us a much better view of what x's fall under this requirement of being less than or equal to -63. So I'm just going to make a quick line graph here. And Natalie is getting a little restless. So there's -63. And if I mark this on the number line, it'd be like that. Anything that was less than -63, anything and any numbers that get graphed on the number line satisfy this inequality. Okay. So that's kind of the first difference. It's less procedural and more conceptual. Conceptually, you're not looking for the one single x that works in the inequality. You're looking to describe what those x's are like, and in this case they are less than -63. There you go. Okay, let's look at another example, and we'll look at the only procedural difference between solving equations and solving inequalities. So I have 4x minus 7 is greater than x plus 2. I need to get all of my x's to one side, and so I'm just going to do minus 4x, minus 4x. And while I'm here, let's get that plus 2 over to the other side too, so that I have -9 is greater than -3x. Okay. Now to wrap this up, I need to divide each side by a -3. And this is where the one procedural difference between solving equations and solving inequalities comes into play. If you multiply or divide, so you have to multiply or divide both sides by a negative. If you multiply or divide both sides by a negative, you flip, there we go, you flip the direction of the inequality. So instead of greater than, this is going to be less than. This left side works out to be +3. The direction of this inequality flip-flops. 3 is less than x. Or if I read it the other way, x is greater than 3. Okay, so to graph this, there's 3, and if I want all the x's greater than 3, so 4, 5, 6, 7, 8, and so on. Okay, I only flip the direction of the inequality if I multiply or divide both sides by a negative. Okay, and it's what you are multiplying or dividing by, not the numbers that are in the equation. So in this first example here, I had a -9 on this side, and that was fine. I multiplied each side of this equation by +7, and the direction of the inequality remained what it was. Okay, in this new example, because I'm dividing both sides by -3, that's when I flip the direction of the inequality. Okay, now you're not guaranteed to run into this in any one problem. To some extent, it depends on how you solve it. If I restart this problem again, I've got 4x minus 7. Come on, 4x minus 7, and that is greater than x plus 2. If I were to start this by subtracting x to the other side, 1x, and then adding 7 to the right side, I'd get 3x is greater than 9, and the problem would work out pretty much the same. Okay? So you don't have to, I hate that it keeps doing this. You don't have to necessarily, you won't always multiply or divide both sides by a negative on any one particular problem. Sometimes it depends on how you solve it. But if you end up in a situation where you do multiply or divide both sides by a negative, go ahead and flip that inequality. Okay? I think that's enough. We'll stop here. Have a great day. See you tomorrow. Bye.